Lesson 5, black holes. We'll get to black holes actually tomorrow, but first of all, let's look at asteroid impacts. There's a joke in astrophysics that says the reason dinosaurs went extinct is because they didn't have a space program. If they'd had a space program, they could have deflected the asteroid. As a matter of fact, right now, SpaceX has actually launched a probe, and its goal is to impact with an asteroid with the intention of seeing whether that can deflect it. Just launched, I think, yesterday. So this is very timely. Suppose a 45,000 kilogram asteroid is traveling at 5.67 times 10 to the 4th meters per second at a distance of 1.2 times 10 to the 7th meters from the center of the Earth. Ooh. Alessio, what does A want me to find? Does it want me to find how much work? Because it didn't say how much work. Are we in a stable orbit? So, Alessio. Are any of these zero? Where would potential energy be zero? If we started all the way out at? We're not. Where would kinetic energy be zero if we were at rest? Are we? So this is going to be a lot of writing, but also asteroid impacts, kind of nerdily interesting, I think. I'd like to know how fast it's going to hit. So, okay, a half little m v initial squared plus mg. Oh, why can't I go mgh? We're cosmic here. Negative big G, big M, little m over R initial equals a half mv final squared plus negative big G, big M, little m over R final. Must. Is it out at infinity? Is it ever out at infinity? Then it's got potential energy. It'll fall. I mean, okay, the speed isn't affected by the mass. The damage is very much affected by the mass, but the speed, no. What are we trying to get by itself? Oh, wait a minute, then I don't want to cancel out the m's, do I? Because if I want to just find out the kinetic energy, m's don't cancel. If I was calculating speed, m would cancel, but they want the kinetic energy. Let's get the KE final by itself, and it's the final. Let's get that by itself. How would I move this over? Yeah? I would add it over, yeah. I'll get this, a half mv final squared, that equals a half mv initial squared, plus negative big G, big M, little m, all over R initial, plus big G, big M, little m, over R final. Is that okay? I plussed it over, and then instead of saying equals a half mv squared, I also moved the equals a half mv squared over here because that's where he's seeing it by itself. I guess it's time to type because they want me to get this. Okay. In fact, you know what? Instead of writing a half mv squared, I'm just going to write KE final because that's what they want me to find. 0.5 little m v initial 5.67 times 10 to the 4th. Don't forget the squared. Minus big G, M, 5.98 times 10 to the 24. 45,000. What's our initial? 6.38 times 10 to the... No, that would be for launching from the Earth. We're landing up on the Earth. Our initial is the space one, which I think they told me 1.2 times 10 to the 7th. I don't know about you, but I think this is the first equation that I've run into this year. I can't fit it on one line. Plus, same thing, times same thing, times same thing, over 6.38 times 10 to the 6th. Whew. Yeah, Hannah, it's time to reach for the calculator. And Hannah, I think I'm going to evaluate each one of these one at a time to like 5 sig figs. So I'm going to go, first one should at least work out okay. 0.5 times 45,000 times 5.67, scientific notation button, 4 squared. For the kinetic, you get 7.2335 times 10 to the 13th. Or am I wrong? Yeah? And I'll round off after the 0 there. 7.2335. Am I wrong? Did I give you a radius or an altitude? Okay. And then there's going to be a minus big, you know what? I wrote the minus. So 6.67, negative 11, 5.98, 24. And what you're seeing, Ronan, is there a lot of ways to make silly mistakes to boot? Yeah. Sorry. It's rocket science. We're expecting it to be easy. I get negative 1.4957 times 10 to the 12th. And then plus, same thing, 2.8133 10 to the 12th. Yell at me if I've done something wrong. I got 7.365, so 7.37, 7.36, depending on what you rounded off along the way, times 10 to the 13th. Is that a lot of energy? I don't know. I don't know what's big. Well, I looked this up for all of you. The atom bomb that exploded over Hiroshima had around 6.3 times 10 to the 13th joules. Atom bomb. Asteroids hitting the Earth are not good. This is not that big an asteroid. 45,000 pounds. That's not a very big rock, actually. Kilograms, you're right. 45,000 kilograms. Not that big a rock. Small, probably about the size of my classroom or smaller. Some of it would be losing. So what we're making the assumption that this is the mass that impacts. And yeah, Caden has raised a good point. We would be losing mass for a changing mass. You need calculus. Yeah, we're doing right now either worst case scenario, none of the mass vanished, or worst case scenario, this is with a mass that made it down to the Earth. But then that would mean that there was more kinetic and potential energy that we lost along the way, and so it might be going even faster. How fast would it be traveling on impact? How would I get the V by itself? times by 2 divided by m square root. 2 times the kinetic energy divided by little m square root. 2 times answer button divided by, what was little m? 45,000? Square root. And I get 57,000 meters per second. So about 57 kilometers per second. Well, that means it would be in the atmosphere for about 3 or 4 seconds. So it would burn, but it's hauling. So asteroids are capable of doing a tremendous impact, like the ones that we believe destroyed the dinosaurs, and like the asteroid that's due to hit us in 2027.